In this video, I will review some questions that will help you to do the unit test on kinetics. So the first question is, given the reaction A plus 2B gives C, and we have three trials here, and the question is asking us what is the rate of disappearance of B in trial 2. So I just have to look trial 2, and the rate of formation is given for C, and I had to look for the rate of disappearance of B. Okay, so for that one, what I have to do is I have to look in the equation and look at the stoichiometric relationship between 2 and B and C, that is going to be 2 and 1. So that means if we are getting 1 mole of C, we have to say that 2 moles of B is disappearing. So if we have 2C, we have to say double of that. So if the rate of appearance of C is 7.2 to the power negative 4, double of that one will be 2 times 7.2. That will be 14.4 times 10 to the power, that is 14.4 times 10 to the power negative 4. So in the answer choices we don't have 14, but we can see the scientific notation, that is by moving the decimal. So the negative 4 will change to negative 3. So the answer is 1.4. The next question is, a freshly exposed surface of metallic sodium tarnishes almost instantly if exposed to air and moisture, while iron will slowly turn to rust under the same condition. In these two situations, the dash refers to how quickly. That means that is nothing but the rate of reaction. So the rate of reaction, how fast it will happen, refers to how quickly or slowly the reactant turns into product. The next question is, which energy profile represents the reaction that would occur at the lowest rate at a given temperature? Lowest rate means I have to look for the slow reaction. So slow reaction will have a high peak. So I will just see the peak from reactant to the highest energy level. 1, 2, 3 lines here, and here 1, 2, 3. 1, 2, 3, 4, and here I have from reactant 1, 2, 3, 4, 5, 6. So this is the highest peak. So this is going to be the slowest. So here this is the one we have to mark. Okay, because occur at the lowest rate. And now next question is, a proposed mechanism for the reaction W2 plus X2 gives 2 Wx is given here. Step 1, step 2, step 3. And we have only one slow step here. It's not necessary that always the slow step in the beginning. So it can be at the end or in the middle, anywhere in the steps. Okay. But in this particular case, it is the first step. And it depends on which one, the rate law. What's the rate law for this one? So that depends only on the reactant here. All right, so that means rate equal K concentration W2, that is the first one given here. It does not depend upon X2, so we don't have to pick the rest of it. Only this is the right answer because that is the slow step and only W2 reactant is there. All right. The next question is, the half-life of a first order reaction A gives product is 2 minutes. When the initial concentration of A is 1 molar, what will be the half-life of this reaction when the initial concentration of A is 0.5 molar? So since it is first order, I don't have to worry about any numbers here. So it is written, it is first order. So first order, we know half-life equals 0.693 divided by K. It does not depend upon the initial concentration of the reactant. So I can say that the half-life is going to be the same. So I will just mark 2 minutes. Next question is, what is the order of the following reaction with respect to ozone given in the rate law? So rate law is given here, rate equal K, concentration NO, concentration O3. I can see that the power is only 1 and 1. That means the order is 1 with respect to NO and order is 1 with respect to O3. Okay, so they are asking only for O3, so I just have to say with respect to O3 the order is 1. And in case if it is asking overall order will be 1 plus 1 equal 2. Okay. Next question. Give the characteristics of a first order reaction having only one reactant. That means first order reaction, we can say that rate equal K concentration of that reactant. So here the rate of the reaction is not proportional, no. The rate of the reaction is proportional to the square root, no. The rate of the reaction is directly proportional to the concentration. That's the one. And our next question is, based on the experimental data given in the table, what is the order of the reaction with respect to B? Okay, so with respect to B, what is that one? I just have to see what will happen to the rate of reaction when I change the concentration of B. So A is remaining same here. So trial 1 and trial 2 I will take. And what happened to B that time? We are doubling that one. When you double the concentration, and what happened to the rate? The rate is quadruples. That means it's going to be the second order. So I have to say that is with respect to B, it's going to be second order. Okay, the next question is, which of the following will lower the rate of reaction? The reaction rate will be lower from the given answer choices. We can see that by decreasing the temperature. And then adding an enzyme means that's a catalyst. It will increase the rate. Breaking, that means you are having more surface area, so it will increasing the amount of solute dissolved in a solution. That means you are increasing the concentration, so it will increase. Only in the case of temperature it will decrease. Next question. An irreversible reaction A plus B gives C is carried out under various conditions, but always with the B initial concentration of B greater than initial concentration of A. Plots of 1 over concentration A as a function of time for each reaction are linear. That means when you plot the graph 1 over concentration A with a time, we are getting a linear graph, it says. And the slopes do not depend on the initial concentration of B. Okay, that means B is not involved in that. And what is the rate of reaction under this condition? Right, and now we can say that this is 0, 1, 2, CLR. That is a reciprocal, that's a second order with respect to A, and B is not involved, so I can just pick that one. Rate equal K concentration of A square. All right. Next question. The following reaction was determined to be elementary. That means this is again for the reaction mechanism. So I have to account for both here. What is the overall order of the reaction and the units of the rate constant K? So the overall reaction will be rate equal K concentration A, concentration B. So with respect to A and B, it is 1 to 1. So the total will be second order. So the general formula for finding the unit of K is m to the power overall order minus 1 and times unit of time. We had to remember that, right? So 1 divided by, since it is 2 minus 1, unit of time here is not just time in the answer choices. So I will just write like that. 1 over m, 2 minus 1 is 1, and the time. So we normally don't leave it like that. We will just take it to the numerator, m minus 1 time to the minus 1, but in the answer choice I don't see that. So that means molarity I had to change. Molarity is number of moles over volume. Volume they have written as liter. So moles they have written mole and liter. Since it is inverse, I have to reverse it. M inverse. So liter over mole, and that time is also I'm taking now in the denominator. So that's a unit I can see here matching. All right. Next question. The graph shown below depicts the relationship between concentration and time for the following chemical reactions. So 2A gives C, and the graph is log, so this is second order. So it is asking the slope of the line equal, so we know log concentration is AT equal negative KT plus log concentration A0. So this is our slope, so I will pick that. Okay. Next question is, the initial concentration of reactant in a first order reaction is That means initial concentration is given and the rate constant K is given. K is 0.75 second inverse. And this first order, what is the concentration in moles per liter of the reactant? So time is given 0.5. So I will just plug it in my first order reaction formula. Okay, so that is negative kT plus log concentration A0 and log AT is the one they are asking, so negative 0.75 and time is 0.5 second, and I will just write log of concentration is given as 0.27. When you plug it in the calculator, when you multiply this one, you will get 0.75 times 0.5 equal, this is negative 375 plus log 0.27 ln, look in the calculator ln and 0.27, close the parenthesis and we will get negative 1.309. So I am just rounding that one. So when you add them up, 0.375 plus 1.31 equal negative 1.685. So then that is log concentration AT. I just need concentration AT, that we call e to the power 1.685. So what you have to do, second ln, and you can see that you can press the negative at the bottom and 1.685 close parenthesis and you will get 0.185, that approximately equals 0.19. That is going to be your answer. Next question, which of the following likely accounts for the difference between reaction path 1 and reaction path 2? We can see that temperature is not the case because I don't see any temperature here written anywhere. So I can see that presence of catalyst. So probably yes, catalyst will lower the activation energy. It will take in a different path we learned. So that's the one I'm going to pick. Actually, it is not in path 1, it is path 2. Okay, because path 2 is the marked here path 2. So that is why the activation, the activation energy is lower in that case. Okay, the next question is, given the following balanced equation, determine the rate of reaction with respect to NOCl. So NOCl is the product and 2 is the coefficient. So it should be 1 over 2 and it should be plus, and change in concentration of NOCl divided by change in time. So I have to look for that. So that's going to be this one. And now write balanced reaction for the following rate relationship are true. Okay, so here it's negative, so that is going to be the reactant. There is a coefficient 2 and this is the reactant. So these are all positive, so these are products. So I will write 2N2O5 will give you 4NO2 plus O2. So that is going to be 2N2O5, I can see here, 4NO2 and O2. Next question is, what is the overall order of the following reaction given the rate law? Okay, rate law, so here it is 1, here it is 1. We explained already, that is 1 plus 1. Here the overall order is going to be 2. The rate law of a reaction is rate equal k d to the power 2 concentration x to the power 2, which are the units of the rate constant here. So I have to find the overall order, that equal 2 plus 2, that equal 4, and then 1 over molarity, overall order minus 1, unit of time. Okay, so that means 4 minus 1 is 3, and unit of time, so that equal m to the power negative 3 time to the power negative 1. And now next question gives product in an experiment. The initial rate measured in several different initial concentration with the result shown in the table of in the table. Okay, so then point 0.1 changes to point 0.2 is doubling, 0.15 changing to 0.03 is doubling, double first order, and for the first order it will be m to the power 1 minus 1, and the unit of time is second, so just second inverse because it will be 0, m to the power 0, so we don't have to put it in the unit. So the answer will be this one.